Foldable robotics is the application of a laminated mechanism as a means to simplify the control or motion of a robotic. This phase of the project involved development of the side pectoral fins for steering and incorporating the previous phase work that involved the development of the tail caudal fin, which is to primarily provide propulsion through water. Kinematic study began by playing with paper layout to develop a path of study. The proposed mechanism was then recreated in Python so different kinematic aspects could be studied, like to check to see if the workspace of the fin was spherical and that it could produce a sinusoidal motion as indicated by the black bars. From the kinematic and Jacobian studies, the forces and velocities were calculated. The forces and velocities were converted into torque and angular velocity to evaluate the selected proposed motor. The laminated hinges consist of a multi-layer device that is created in Pop-Up CAD, which has an outer stiff layers and a flexible inner layer. It consists of an outline and hinge layers, which create key elements that are incorporated into a cut pattern, which then after assembly will allow you to cut your hinge away from and produce a device. With a way to quickly produce laminate devices, prototyping was easy. One area that was heavily studied was singularity. To avoid this, we tried putting a fixed plane at an angle so that way it was never flat, as well as forcing additional angles. We continued to work with the basic 5-bar mechanism. Here we see that the simple 5-bar mechanism, that, while it still has singularity, was able to achieve a reasonable range of motion. Our final design is then incorporated and the hinges are strengthened with multiple layers of fabric as well as plastic. For sensing and testing, pectoral fin was mounted at the end of a force torque sensor. With this, the device is put in a tank of water so that we can measure the torque that the fish experiences. A fish body was needed. The body houses the servos, and on the servos has the horn and a custom horn, and that is repeated 4 times. Then the 5-bar mechanism is put into place, and the previous tail is incorporated into the body. Side fins are added to help add more force, and it's all closed up. All that's left is to add some motion. Here we see the final 3D printed fish, all assembled and with everything housed in, and the servos coming to life and motion starting to be seen. To improve the performance, machine learning was incorporated into the design. This involved using MATLAB, Python, and Arduino. During initial testing, it was discovered that it was out of sync and marked the code needs to be changed because it destroyed the previous test. Further work also involves incorporating all 5 servos and a large tank to do testing in. Thanks for watching.